So
This
today we will be
conference will now be recorded.
basically our session starts from today. So we will be starting with the introductory module where we speak mainly on the chaos engineering concept. Just a minute. Let me know if you get some background noise. Okay.
No, we are able to hear you properly.
Yeah. Thank you. So let me share my screen. So today we'll be looking into some basic the introduction. Yesterday we were speaking mainly on the course and how the course will proceed and all. So today we'll be starting with our sessions, and it will be the day one. So we'll be starting with the introductory module where we understand like basically what is chaos engineering and how like what led to the rise of chaos engineering, what is the different principles in chaos engineering, and all those concepts will be uh, like covered in the introductory module, which is module one. And we will also try to see one basic like how you use gremlin to generate a basic attack, like maybe a cpu attack, where like how what's the basic setup you do, though that we will be seeing in detail in the coming sessions. But since this is a day one, which is a demo session, and I wanted to like show you how we generally do using the gremlin. So we'll be doing that also, one simple hands-on experiment. So let me share my screen. Is my screen visible? Yeah, I hope my screen is visible to all.
Yes.
Yeah. So let's start the module one, which is the introductory module we have. And here we will be mainly focusing on the concepts of chaos engineering, where we speak about the introduction and all. But before we go to that, I wanted to give you a quick overview of what all tools we'll be using. And as I said, we will be using Grafana, we'll be using Prometheus, Jenkins, and the demo application which we'll be using is a SockShop application, which is a microservice based application. Uh, so this we will be deploying into our Kubernetes cluster. So how the like the application will look like is, so basically we will be having a Kubernetes cluster with different namespaces and pods. I will explain you all this. What are namespaces? What are pods? What are the significance of all these things? But so we'll be deploying, like we'll be doing fully like, with this setup fully on our AWS instance, and we'll be also learning how to deploy the application. What are the different how to read a YAML file from that? Because if you learn that, you will be able to debug those things also. Like for example, how to get the logs of a pod and all. So now if you see, this is the deployment which we have done. This is a small e-commerce sort of application. So if we do we want to access this application, just so the application is like a sock shop application. Basically it's a simple e-commerce application where you can buy socks. Okay, so and it's a microservice based application. So if you see the architecture here, so if you see the architecture here, uh, like just not don't focus on the terminologies which I use like microservices or pods and all, because I'll be explaining you all of these in the coming sessions. but this is just a quick overview of what application will be using for the attacks and all. Okay, as we progress in the Kubernetes section. So this application is built over for mainly order, payment, user. These are all microservices which we have, and these are on, for example, payment is on Go programming, and cart is on Java programming, shipping is on Java. So it's a mix of services which you have. So we will be learning how to attack the services, how to attack the containers, how to attack the Kubernetes cluster whole as such, and what are the different things which we need to take care using this application. Okay, this is a microservice based application. So using this, you will also get a clear understanding of what are microservices, how you clearly attack those services, how you target specific services for attack and all. Okay, those things will be very clear with this application. So if you see this application, it's a basic application where you order stuff. Okay, so for example, if I log in, let me see if I have some login. So like just you can just browse the product. So there's a catalog service. Then you can add the product to the cart. Then once you add the product to the cart, you need to add the shipping address payment here itself. Okay. So and then you need to go to proceed to checkout. You can see the order details in my orders. So it's a simple application, but it's a microservice based application. It's not like some other application which is not on Kubernetes. But so basically what all you see here, like the catalog, the account, all are running as services. Like if you can see cards, catalog, front end. So basically this will allow you to do multiple things, like for example, running a Kubernetes level service attacks, learning what's horizontal pod auto scaling. So all these stuffs will be we will be able to learn using this application. Okay, so that's what the main aim is. So just wanted to give you the overview. This is the application which we will use for our demo. Okay, demonstration of all the attacks and creating the use cases and all. Okay, so yeah, now coming to Gremlin. Before I jump into Gremlin, I will just quickly start with the module. Okay, let's have an introduction first. Right. So now, rise of chaos engineering, if you see, it's mainly dependent on few things. Okay, especially the rise, especially if you see from like the time when the Chaos Monkey was released by Netflix. Can anyone say why Chaos Monkey was released by Netflix? What was the reason? Why anyone read about it or anything? Like, what was the reason behind why Netflix released Chaos Monkey? What was the need it faced before some 7 years, 7 8 years back?
So they need the application 24 by 7 and they need to cater multiple users. So they need high availability of the system so that the user experience is not disturbed.
True, yeah. So that's the one of the reason. But the main reason why Netflix wanted some tool which can test the infrastructure better than other testing practices is because they were moving on to cloud. Okay, they were moving on to AWS. So that was the time when Netflix infrastructure was totally moving on to AWS, and when they were moving on, when the technology transformation was happening, they were facing a lot of issues. Okay, especially due to the cloud system. So cloud is one of the major drivers of chaos engineering, and the second is the distributed systems. Now, these distributed systems we need to understand very well, because it's not that. So we need to understand why the distributed systems are required and why they are getting hold of the market. So anyone, like, can you explain what do we mean by a distributed system? What's a, let's say let's compare, okay, monolithic systems and distributed systems. What are the
Uh,
major differences? Yeah.
yeah, it means like customers will hit the use the Netflix application from the different locations.
Okay, that is one of the properties. Anything else, like, so
Easy
what do
to
you mean by
maintain.
okay, so why these are like the consequences, okay, like of something, but what is a system, like what is it happening in the system? Okay, let me
So like
explain
in,
you that. Okay, yeah, let
It's
me
all
explain you
lying on
that.
it's all lying on different machines, right?
Okay, that is one of the properties again, but like just wanted to cover. Okay, let me explain you that a bit.
So it is having a distributed architecture node micro node master slave client. So every node is capable of handling everything.
Yeah, so I just basically I want the definition or want the explanation in terms of the so let's say the functionalities which are running in that. Okay, so what happens is now when you have a distributed system, let's compare for let's explain let me explain you first what is a monolithic system, generally how it looks like. Okay, so let's say I have an application like Amazon. Okay, an application like Amazon. Now what happens in Amazon is, you let's say you have different functions like orders, where all the, like I'm grouping the functions. Okay, so where these orders have other functions, let's say ordering, then checkout, all are in this orders group. Okay, second, let's say I have accounts. Now accounts, let's say I'm grouping all the functions like login, log out, etc. Let's say account details, etc. in this accounts group. Then third, let's say I have one more, like let's say payments. So all paying card details, card update, such functions will be there in the payments. Okay, now let's say there's one more like core. Okay, which basically take location services like getting the user location, then all those. Okay, so something like that, some background configurations and all. Fifth, let's say I have a catalog service which mainly defines like catalog browsing function and product product management and all those in the catalog. Okay, so let's say these are the basic I can say basic functions which are there in the Amazon application. Okay, so just a minute, the application is, yeah. So these are the basic five things which you have. Let me reload this once. Yeah, sure. Faraz, you can contact Kumar, or I will ask Kalyani to contact you. Thank you, Faraz, and have a good day. Yeah, so let's continue. Uh, now I have a system where we are looking into the five different grouping, okay, of the functions. Now let's say if it was a monolithic system like the old system which we had. Now in those systems, what will happen is, if you have these services like order, accounts and all, they will be all linked to each other. Like for example, if I have order, if I have order and I have accounts. So now when I say order accounts, there are multiple functions also, okay, which are grouped into order. So imagine it that way, accounts. Then we have, let's say, catalog. Okay. So when in monolithic systems, what was there? Like these were all linked with each other. Like for example, accounts might, saying in terms of, let's say, coding also, okay, source code. So the code, okay, if you see, they were all linked with each other. Like for example, accounts might be using some order classes to write the code. Okay, order might be using some accounts classes, functions, okay, which to write the code. But with this, what happened? There was a very much high dependence of the developers with each other. Like the person who was developing orders, there was a high dependency with accounts also. There was a mix actually. So people were doing activity with like as if they were sharing all the with each other. Now, but what happened with the distributed systems is, the order, accounts, catalog all were linked using something called an API. For example, I'm saying there are different ways to link it, but one of the most common way is API. Can anyone say what's an API? If you have worked on that,
So
if
it's
anyone has
like
worked on.
integration between few functionalities.
Correct. Yes. So in this way, what happened, right? So initially, now what was happening? Order team wanted to know what all functions accounts was using, and those functions has to be ready before order can develop anything. But what happened with API is in the planning stage itself, order set to accounts that these all things you should send me in the API. Like for example, I need the username, I need the user ID, and let's say date. For example, I'm saying, okay. So these details they will send in the API. That order has agreed with the accounts. So what accounts will do? They also know what to send to orders. So they will develop an API. Accounts team will develop an API with this respect, this parameters. Now order already knows. Okay, this is what it will get from accounts. So what order will do? Order will start developing with a mock API. So the API will be mocked when they are developing it because they already know what the API structure will be. So there is no dependency between order, accounts, and any other with each other. Okay, so they develop everything separately. And now this is with respect to the code. Okay, with code they have become separate. Now what about the infrastructure, right? So infrastructure also, what they did, they divided it into services: so order, accounts, like cards, catalog. So what happened? Even deployment also they could do separately. There was no dependency with each other, and this is called microservices. Maybe I will explain you more detailed this when we go to the next sessions. But yeah, this is what generally we call the microservices. When we divide each functionality or each service in each group of functions into different services. So in this way, what happens is if order development is complete, they can deploy it to orders. If account development is complete, they can deploy it to accounts. Now, if some fixing requires in accounts, they can remove accounts and deploy a new one. Others will not get affected, right? So that all these advantages we got using the distributed system. Are you able to now clearly differentiate between what is distributed system and what is the old monolithic systems? Anyone has any doubts?
Uh, I also heard a term distributed monolith. What is that?
Yeah. So yeah, what's the doubt? Go ahead.
Yeah, so I heard a term called distributed monolith. What is that?
Distributed monolithic. I don't know. Do we use such a word where we? I don't know where you heard it, but generally we use monolithic systems word for the bare metal systems, which is like a single, not a distributed one. As I said, there are no microservices in those systems, but we have a distributed system where we have microservices architecture and all. But I don't know where you heard a combination of both. Maybe somewhere like they are using some systems on monolithic and some on uh, maybe distributed. I don't know.
Okay.
Yeah, because there are situations where you have applications which are hybrid. Okay, hybrid means like let's now here we spoke order, accounts, and all, but there would be some applications which are interacting with these services also, like for example, you have a user data. Okay, so that will not be on cloud. So what they will do, they will be keeping it on the on-premise application. So on-premise when it comes, so generally sometimes this distributed thing will not be there when there's an on-premise application, okay, where they don't have cloud and all. So that could also be a reason why they are saying monolithic distributed system, because they might have both a hybrid sort of concept. Yeah, Guru,
So
go ahead.
Vishnu, what is the difference between what is on-prem application and what is cloud? So why we are moving the application from on-prem to cloud? Just I
Yeah,
want to know difference.
that's a good question. Though we will be seeing all this, but anyways, let me explain you that the on-premise we generally have and off-premise. There are two types of applications. Okay. Now, what do we mean by on-premise and off-premise? Let's say I have an organization, okay, and let's say again I'll take the example of Amazon. Okay, now there is a cloud which is AWS. Okay, now this on-premise means it will not be be sitting on cloud, it will be sitting and which is at my organization. So what do we mean by
Vish-
that? I manage everything. Like off
Vishnu,
premise
like
means it will be
we
on the cloud,
like
which is on the AWS,
yes,
which is managed by AWS, right? But the problem with
Your voice is breaking, Vishnu.
your voice is breaking, Vishnu. Like we
yeah, let
missed
me
that
complete
point.
this. Then yeah. Oh, okay, okay. Sorry. Is it better now?
Yes, yes.
Let me see if I can change my network. Is it better now, everyone?
Yes, Vishnu. Yeah.
Yeah. Okay. It's like sometimes this 5G network has some problem. Yeah. Yeah. So what we can do is, yeah, we were okay. We are on premise and off premise. Okay. So anyone has any problem in that? Like how? What do we mean by hosting? Is everyone aware of that? Mm,
Looks like still that your voice is breaking, Vishnu. I'm not sure
oh,
it is for me or others also.
is it breaking still?
Yes, Vishnu.
It was intermittent, Vishnu. Like
Yeah. When you are starting the difference between on-frame and off-frame only,
Okay.
it's checking.
Maybe my system is not liking that word. I think. Yeah. Let me see. Yeah. Just a minute. Let me connect again to the 5G network. 1 minute. Let me. Yeah. So is it better now? What do you think?
Yes, it's
Yeah, it
better.
is good.
Okay. I'm audible, right, everyone?
Yes, sir.
Yeah.
yes, yes.
Okay. So coming to on-premise. So see, first of all, hosting, is it like everyone aware? Like what do we mean by hosting an application? Before I go to on-premise, off-premise.
So we need to place the application in some of the, where we need to host, where we need to deploy the application that we call as an hosting.
Yeah, exactly. Okay. So as simple as that. See, now you have a code. Okay. To run that code, you need a server. Server is also generally a software only. Okay. Now this software, everything has to run on a hardware, right? That hardware is basically called the hosting we generally have. Now this hardware either can be on the cloud. So for example, let's what is hardware? CPU, RAM, storage. Okay, that's what is the hardware all about. Okay, so now this CPU, RAM, storage can be either on the cloud or it can be on my premises. My premises means like, now let's say this is my laptop. Okay, so now this is on my premise. I'm the this laptop resources, CPU, RAM, everything I can use as a server also. I can host an application on my laptop. Okay, so similar to that. So what organization will do is they will keep some CPUs, RAM, storages, and on that they will deploy some application that is called on-premise. And what is off-premise is which is on the cloud. Now, can anyone say why we divide this like this, on-premise and off-premise? Like, why do I need it? Why do I need some application under my control and some it's okay on AWS? What could be the main reason?
Data
Security and
security.
latency,
Security?
Exactly.
latency as
So
well.
exactly, latency also will come, but the major thing is security. Okay, so generally if you see any on-premise applications, they will have some very critical data like some user data or some banking data, some credit card details, so those things and all. Because see, though it is on cloud off premise, which is on AWS, though AWS says privacy and all those, but surely they will be able to see the data, right? Obviously they will, it's on their premise, though they say it's privacy, everything and all, but we know, like, if they might have control over it, right? Because it's their infrastructure, they will be able to see what is going inside and going out and all. Okay, so if we want to protect our data, we go with the on-premise. Now my question to all of is, so what all can I put on cloud? How do I decide? Like, let's take the example of Amazon. Can you say me two examples which I can put on premise, and two examples which I can put on off premise, the services, let's say.
Product details, pricing details,
Yeah, so
you can put on
catalog.
cloud.
Yeah,
Yeah,
true. Catalog, then the product details, items, and all those, all sort of things. Those things I can, the code related to that, I can put it on cloud. Okay, but on premise, if you see the accounts, right? Accounts, everything
yeah.
will be on premise because the user details, which is very critical, and also payment details. Okay, that will be on premise. Even order details also I can put on cloud, not a problem, because it's just order IDs, what they are ordering and all. Okay, but payment is very important, the credit card details and all those, which are very highly which has to be highly secure. Okay, even the address and all, address, mobile number, so these are like privacy issues, right? So that should be on premise. Now, I hope most of you would be clear what's off premise and on premise. Is anyone having still doubts, like what's on premise and off premise?
So you mean to say like on-premise is security compared to AWS cloud, right, Vishnu?
Correct, yes, security in terms of data. Okay, data.
Okay. In that case, like nowadays, like all applications are moving from on-premise to cloud, right?
We can't say all. See, what happens is everything is hybrid now. We can't say all, because hybrid is what the concept, because what you are hearing is that all the application are moving on to cloud, but it's just moving on to cloud. All the sections of application are not moving on to cloud, right? There's a difference between
Okay,
both the
okay.
statements, right? It's
Okay,
a
okay.
hybrid.
Whatever the security we can feel, those it will be in on-prem only. Remaining things they will be moving to cloud, might be.
Cloud, yes. See, generally, no architect will suggest to keep your data on cloud because it is very unsecure. But let's say you have an application or a business where the data is not that important. Like, if it gets shared, also not a big deal. In that case, they can move fully on cloud. There's no problem. But generally, I don't think any business will have such a concept where they are fully on cloud, because it's very dangerous. Okay, because even what will happen is, see, the data has to be secured, and if some, like, though AWS will give you a lot of SLAs, lot of agreements and all, but if you lose your data, it's your business, right? Getting my point?
Got it, got
You
it.
can give some case or something on AWS, but that case will run for 20 years, but your business is gone, because your user data is gone, credibility is gone, everything is gone. Okay, so that's the reason. Okay, we can go for on premise whenever required, right? So coming back to microservices, and yeah, so are we clear now what's a distributed system?
Yes.
Yes, Vishnu. Yeah.
Yes.
So that is one of the reason. Now the problem with this is, right, there's one new problem which arose with this distributed system. Though the developer's life became simple, okay, developer's life became simple. Why? First of all, no dependency. Okay, they can easily deploy, generate code, write codes. There's no dependency with other coders, okay, other developers who are developing other services. Second, they can choose anything. That's what the major advantage they had. Like, for example, now order and accounts both are linked using API. Now API is a global language, right? The language doesn't change. It's a global language, whatever you choose. Now, order, what they will say, right? Anyways, we are interacting using API. Accounts is also saying we are interacting using API. So the code which we develop, let's use different thing. Like, I will use Go programming because my technical expertise is Go. Accounts might say I will use Java because my expertise is in Java. And similarly, order will say I will use DynamoDB. The accounts will say I will use, let's say, MySQL DB. So within the service also things changed, the language on which it is developed, the DB which it is using, the infrastructure inside the code, okay, what they are using also changed. Now due to this, what happened, though again life of the developers became simple because they could apply their own expertise. But the problem, if you see here, who was the most affected person here? It's the
Backend.
testers, right? Now why the testers got affected? Even functional testers, you leave it, functional testers, okay, they are working again maybe service wise, so they will be working on one service separately. But think about performance testers, what happened? They work on an integrated environment, okay. So I'm saying an example, okay. So let's take the example of a performance testers. So now the order accounts, everything is working in integrated level, and these all things are are communicating with each other, which is totally different things, but all communicating using APIs. So the complexity of the problem increased. So the problems which the functional testers couldn't catch due to the integration issues, and which the performance testers couldn't catch because they are not doing functional testing, they needed one testing domain which could catch all of these problems, and that was chaos engineering basically. So chaos engineering mainly deals with this only, like the distributed systems, why the complexity which these distributed systems add, right, due to all this different things, different combinations, what will happen, okay, to our system under these combinations. That's what this chaos engineering is all about. And as I said, obviously we know, chaos engineering, as we spoke in the first session itself, it focuses more on the recovery and the user experience, how the user will be affected, because ultimately the business value or the business brand value is totally on the customer experience. If your customer experience is not good, you cannot create loyal customers, right? So that is also a point where chaos engineering mainly focuses on. Now is it clear, like why distributed systems or cloud architecture and all led to, and what was the need of a new testing practice like chaos engineering?
Uh, sorry, I missed, Vishnu. Can you please
Yeah,
tell again what you just said related to functional testing and integration testing?
yeah, okay. So see, what happens with the functional testing is, right, generally when you have services, they will be testing like one tester for each service, okay. So they won't be interacting with each other, okay, these testers. And also there will be one integration testing in the int environment generally. There one tester will be testing the functional things related to the integration and all. But what happens now, though both these everything is happening, there are some gray areas which will be missed, okay. Though performance testers are integratedly testing the component level performance issues, they might be missing, okay. Now yeah, even so, though performance and functional every issues have been resolved, there will be issues with respect to what complexity your system has. Like for example, now even let's say your order service is using a programming language like Go, and they upgrade the Go programming, okay, let's say the version, okay. When this version upgrade will happen, maybe your order service will show different sort of behavior which your functional or performance testers couldn't catch, okay. Your system, like, it's more sort of your system will show outages, your system will crash, okay. And you will be seeing like it's not due to the CPU or RAM or some traffic, it is mainly due to the configurations what you have. So all those things will be captured only when you do a chaos engineering activity. Clear everyone? Now,
Yes, yes.
yeah. So that's how mainly if you see how the chaos engineering got like we can say the rise of chaos engineering. Okay, and again as I
If
said,
you could,
yeah.
if you could give one example as well, what kind of scenario related to the system configuration might be
Uh,
present?
okay, yeah. So take an example. Yeah, I wanted to show you the Gremlin example, so little time constraint. But anyways, I will show you this. Okay. See, for example, now if I have a service, let's say order service, and there is one system called SQS, okay, let's say, and I have a DB called DynamoDB. Okay, this is the system which I have. Generally, what will happen? Let's say as ordering comes, like let's say 1,000 orders came, the 1,000 orders will be filled in SQS, and DynamoDB will write 100 at a time. Okay, so that's how, let's say, the system is designed for. Let me continue. Can you go on mute if someone can speak? Yeah, my voice is audible, right, everyone?
Yes, Vishnu.
Yes,
Yeah.
Vishnu.
So I have a order system, and SQS is basically a queuing service. Okay, queuing service means like if you get 1,000 orders, that 1,000 order IDs will be stored in SQS for some time until DynamoDB can totally ingest it. Okay, so DynamoDB is basically, let's say, ingesting 100 per second or something like that. Okay, and 1,000 are being stored here. So totally it will take 10 seconds for all the 1,000 values to get ingested into DynamoDB and this to become 0. Okay, so total 10 seconds it will take. Now let's say there is a situation where DynamoDB fails, like DynamoDB is totally crashed. Okay, so what will happen? Order is coming 1,000, and this is building up. Okay, let's say it became 1 lakh. Okay, now my DB is up again. Now this 1 lakh values to go into DB, it might take not 10 seconds, it might take 5 minutes, let's say. Okay, now is my DynamoDB able to handle all those sudden flow of request? That I haven't tested, right? Because even in performance, when we are doing, we will be testing with the volume, but we never tested what will happen when the DynamoDB is not there and suddenly it is coming up again. Are you able to understand the scenario now?
Yeah.
Right? This is one of the very basic example where you are applying chaos engineering. So what you do, you attack DynamoDB, you kill the DynamoDB for 1 minute, and then DynamoDB, you have to see whether it is coming back. That is first thing, very important, because that is also there in the algorithm. It should come back. It should ingest all the order IDs properly. Now, what will happen if it doesn't ingest the order IDs properly? Like let's say there were 10 lakh order IDs, and after some time, if I see this 10 lakh is not becoming 0, it is some 1,000. Okay, is it okay?
Oh no.
Because this 10 lakh should become 0. That means all the 10 lakh values has been written to the DB. Now if I see 1,000 value, that means 1,000 order IDs have been not written to DynamoDB. That means it's a problem, right? Like let's say Guru is ordering something, okay, and his order ID has not been written to DynamoDB. Then that means when he goes to the account and sees, he will not find his order ID, which is a disaster, right? Able to get my point, everyone?
Yes,
Yeah.
Vishnu.
Right? So these are
Uh,
some situations where you apply chaos engineering to. Okay, yeah, go
yeah.
ahead.
So one question. You said like if suppose DynamoDB is down and later on the number of requests get increased.
Hmm.
Suppose they have been now 1 lakh. So this
Hmm.
kind of scenario we cannot test in performance testing. Is it the case?
Correct, yes, because you have to bring down the
Uh,
DB, right? DynamoDB you have to kill and bring, and automatically DynamoDB should recover in a minute, and this all process should be happening as a chain sequence, right? That you need to test whether it is happening.
okay. So basically, you are saying is the extra that chaos engineering is providing, bringing up this DB back and then trying to ingest the data in it, right?
Correct, yes,
With performance testing, we can just try out the load by increasing the load and check if it
correct.
is getting
Hmm.
ingested or
Yes,
not.
yeah.
So extra
Yeah.
work is it is providing high availability
Yeah, true. That
and
is,
recovery.
I will not say high availability, but it is, first of all,
Recovery.
chaos engineering is all about, yeah, recovery. Yes, exactly. That properly it should recover. Not only that it is recovering, but it has to properly follow all the norms of recovery. Like as I said, SQS should become 0. The DynamoDB should take all the values, ingest it properly. And when this is happening, it should not happen that other transactions which are already happening should get affected, right? That is also important. Now 1 lakh order IDs the DynamoDB has to take. Now let's say if my DynamoDB is taking, rather than 2 minutes, it is taking 5 minutes to recover. This 1 lakh will become 1 crore inside SQS. And is your SQS capable of taking 1 crore values? That is also important, right? Getting my point? There are a lot of things here which you can test,
Mhm.
Uh,
Okay.
Vishnu, I
which the
have
things can go wrong. Yeah, yeah, Samir. Yeah.
Yeah, while designing our experiments, right? So do we need to consider all these edge case scenarios also as part of the chaos engineering experiments?
Yeah, that we
Because
will discuss. Okay, so I will. Yeah,
initially you
true,
told
true.
we need to get a good grasp on the architecture part to do
Yeah.
chaos, right? So is
Mhm.
that what you meant?
Yeah, it's same thing, right? So what happens, no, when you are reading your architecture diagram, obviously all this SQS, DynamoDB, everything will be there in that diagram. Okay, so when you're reading the architecture, it's not that only like you'll be seeing. See, it's SQS is also a component like a load balancer, right? Load balancer also you will be obviously testing in chaos engineering. So SQS also is a component which you should test, right?
Okay.
Yeah. Even SNS, if you have seen SNS, right, it's a notification service. Now these are all of AWS, okay, which I'm calling out. For every Azure and every other cloud also, they will have this queuing services, notification services. So SNS is a notification service. So basically, it helps to send the notifications. Okay, that also you test generally. But as I said, for testing SQS, for testing SNS, you don't need to know how to develop those. Okay, you just need to know how you test those. There's a clear difference in that. You don't need to go very deep into SQS to understand how it is developed, but you need to know what is SQS, right? That's a simple question to test it. Yeah.
Yeah.
Any other question? Yeah.
Okay. So one question is, might be it is a little early. Um, that when you said it will be taking care of like SQS is coming back to zero. So if suppose SQS is stuck at 1,000 or 100, so
Mhm.
does chaos engineering takes care of restarting SQS or some doing something purge or something so that it should
See
be
here,
able to
yeah,
recover
yeah.
that?
See, yeah, that's a good question. See, here we are not fixing a temporary fix, okay? That we need to understand. If it is showing 1,000, then developers have to fix it. So when I retest it, that shouldn't happen. Developers have to find out, or even we have to find out if you have a good knowledge on the architecture, why that is happening. Okay, and they have to fix it in the code. The problem is in the code or
Okay.
the infrastructure, right? Getting my point,
Okay,
everyone?
and yeah, and
Yeah.
chaos will help us to identify the issue.
Yes, correct. The tool which we are using like Gremlin. So what the tool will help you? Okay, so Gremlin will help you to bring down that DynamoDB and properly you can monitor what is happening in those situations. And then what will happen is you have to monitor the SQS, you have to monitor DynamoDB whether it is coming in what time up again. Okay, so that you have to monitor. And then so basically Gremlin is making your life simple in bringing down those services or attacking. Like for example, you can add a latency attack to DynamoDB. Like what will happen if you have a latency in DynamoDB? Not only like this is just one use case. Okay, now there can be latency also, right? So what will happen if you have latency? Right? So those things, everything you can test, right? So that's why see no need, generally people get overwhelmed or what all I will test. So the what we do generally is we go one by one. So if you have some 5 services, you make one service resilient first. Then you go to other 4. You don't make all 5 services resilient at once. Okay, so generally how the chaos engineering activity happens is you take orders or accounts or whichever service you want, one, okay, and then you make it resilient first. Then you go to the other services. Okay, so that way you will be able to make your whole system resilient. Okay, yeah, any other questions?
Vishnu, but a developer can bring down the DynamoDB, right? Why we need to use the Gremlin tool?
Exactly, that's a very good question. That's how the chaos engineering activity used to happen before some years, right? But now it's not like that because we can't go to developer every time for every attack. He has to do his work. It's more sort of saying, okay, I am a performance tester, you generate the traffic. But I need to learn Jmeter, I need to learn LoadRunner, right? To generate the traffic. Even developers can generate the traffic without Jmeter LoadRunner. There are different codes to write, okay, like a Python code we can run which will generate the traffic, but that's not a correct way to do, right? We are the testers, they are developing it, we are testing it. So that's a clear. And also the tool which we have has different types of attacks, not only bringing down DynamoDB. You add a latency, you add a packet loss attack, you have a black hole attack. Different types of attacks are there in the same tool. I hope you're getting my point, Jagan, right?
Yeah, got it.
Yeah. Yeah, Helia, go ahead. Helia, I cannot hear you. You can put your message in the chat otherwise, if your mic has
One
some
more
problem.
question. Uh, yeah, one
Hello.
more question, Vishnu.
Yeah, go ahead, go ahead.
Helia, you can go ahead.
Yeah, I was asking like once the services that once you attack like services, let's say if you attack in like CPU or like you detaching a volume, do you specify like how you're going to recover, like a mechanism to recover those services to go back to the previous state?
No, see that is already in the algorithm of the code, right? When that service is done, so we attack it. That's all. The noise we provide, and whatever happens after the noise, your system has to do, and that we will monitor whether it is happening as expected. Okay, that's
Oh,
where the steady state hypothesis that we will discuss. We will before we start our experiment, we will write a steady state. We will write a hypothesis which we will test. Okay, in that
okay.
hypothesis, it is clearly mentioned what you need to look for when you are running the experiment.
Things like the impact.
Yeah.
I mean, how
Yes,
would it? Okay.
correct. Yeah, we will be explaining. Like there are a lot of things coming up. Like for example, now we are at rise of chaos, and there is like for example here we will learn mainly on the principles of chaos engineering. Okay, where we will discuss of the different hypotheses, running an experiment, and all those. So that time it will be more clear. Okay, what we generally do, what's the blast radius, and all those principles. But sadly, I wanted to show you a little bit of a demo on Gremlin, but yeah, time is almost. Yeah, yeah. Go ahead,
One question.
Shravan. Yeah,
Yeah.
or Madhu. Yeah,
Yeah,
someone.
so
Yeah,
yeah, my turn, Madhu. So, what do I say? You said like we can test the service one by one, right?
correct.
So,
Yes.
if suppose we are testing one microservice and they're having a shared database, so my other
Mm-hmm.
services will also get impacted if I'm testing the resiliency over the database as
True.
well.
Yeah, true, true. Yes. Yeah, so in
So
that case,
basically,
there's no problem. Yeah, that's where we have the blast radius, right? So when you are
Mhm.
defining your experiment, you define your blast radius also, and you get all those. I will explain you all this because it's just a jump if I do that
Okay.
now.
Mhm.
Yeah,
Okay.
yeah.
Okay.
So yeah, it will create more questions, and we don't have that much time to cover those questions. Yeah, Rajkumar. Yeah.
Hi, Vishnu. Yeah,
Oh,
maybe I
Madhu.
asked this question
Yeah,
a little early in this training. So I want to like understand like what are the tools? I mean, if I start with GCP Cloud
Mhm.
to experiment chaos, so the basic tools that I need to look into to start with the experiment. So
Yeah.
uh,
So
maybe
currently
this
in this
question,
course. Yeah, in
yeah.
this course, we will be studying Gremlin and Chaos Mesh, which will be more than
Okay,
enough for you. And
okay,
obviously, what all things you can read, maybe like, for example, related to cloud and all, that I will share with you all. Okay, like, for example, if you want to learn more on SQS or SNS or DynamoDB or RDS, okay, that I will share some good materials, which like, but that will be mainly on like just for extra knowledge. Okay, it's not mandatory. You should know all this. Okay, but mainly what is required for you to know, I will teach you everything in this course. There's nothing like prerequisite sort of thing. Okay.
yeah, sure. Thank you.
Yeah. Yeah, Rajkumar, go ahead.
He is not able to unmute himself, Vishnu. He just
Oh, okay.
messaged.
You can then you have yes message me. Oh, okay. Just like can we test different way together like yeah, so we can, Rajkumar. So as I said, but there's a concept called minimizing the blast radius, which we will discuss. So you have to go in that process. Okay, though we will reach that stage, what you said, but it will not start initially. Initially, you start small and then you go to big. Okay, so there is yeah, you can do it. Okay, it's not that you cannot.
One last
Yeah,
question, Vishnu.
yeah.
So this chaos mesh that you talked about, is it similar to like we have service mesh?
No, not like that. There's a difference. Okay, we will discuss that. That time you'll understand. Not
Okay,
that,
but
not very
chaos mesh.
clearly.
Okay,
Mhm.
okay,
Yeah.
but chaos mesh we can do even if we are not using service mesh, right?
Correct. Yes, we can. Yes.
Okay.
Yeah. Samir.
Yeah,
Yeah.
Vishnu,
Go ahead.
like I have one more question. Like you told there will be predefined experiments, right? So if you need a custom experiments kind of thing, like based on our architecture and all, so can we create a custom experiment also,
So
or
see, that for
is it?
that we have Chaos Mesh. Okay, in Chaos Mesh you can create custom experiments. In Gremlin, it's a paid tool. It's more sort of like LoadRunner. Okay, in LoadRunner, your customizations are less, right, compared to Jmeter,
Yes,
because it's a paid
yes.
tool. They will not give you the code to you. So that's it. But what I meant to say is, from my experience, the attacks which are there in Gremlin, to complete them itself, you will take 5 years. What I meant to say is, yeah, so custom ones you will not require, because what all Gremlin has, that will suffice most of our needs. Okay, like you won't be, because even it's not that you do an attack randomly, you do an attack based on production issues, right? So production issues you will be seeing mainly, it will be out of these attacks only, and they are keeping on upgrading it. Like initially they were having some 4 attacks, now it's 8 now, and now it's 12. Okay, and it is increasing as per the market conditions.
Okay.
Yeah, so I
So
don't
suppose
think you
my
will
company,
require some attacks, but yeah, if you need chaos mesh, you can use. Yeah, yeah, Sharma.
yeah. So suppose my company is not allowing to use Gremlin due to some cost issues or something.
Yeah.
So what else can I use?
Chaos Mesh, obviously, you can go with Chaos Mesh. Use
Okay.
it.
Okay, and it
Yeah,
is open source, right?
yeah, but yeah, that risk, but your company has to take. Okay, the security or reliability issues, because it's a open source, you have to do a security testing on it before you can apply. Okay, so you
Okay,
will have a
and the
security
other.
team who, like, generally an organization has it. Like before
Mhm,
you
mhm, mhm.
deploy any application. Yeah,
Yeah. So, like, and chaos mesh is equally, not equally, but it is one of the leaders in open source technology for chaos engineering,
correct.
right?
Yes, you can call out like Chaos Mesh as in open source. Yes.
Okay.
Yeah. Okay, Rajkumar's hand is still up. Maybe I don't know whether you have some question. Arul, you can go ahead.
Yes, Vishnu. So,
Yeah,
so we have various components in our architecture, right? So, is there any specific guidelines to do this experiment against any specific components? For
yeah. I
example,
will be sharing you some checklists and all. You can
okay,
use those to create the plan and all. Yes, I will be explaining you how we do it. Yeah,
okay, thank you.
yeah, yeah. If no more questions, sorry, I couldn't complete Gremlin today. I thought maybe I'll show you a small demo of how you set up the agent and all. But anyways, we can continue in the next session.
One
Um,
last question, Vishnu.
Yeah, yeah, Samir, go ahead. Samir or Jagan?
Vishnu.
I don't know. I'm getting.
Y- Yeah, one question is like we are using you told we'll be using chaos mesh, right? So we'll be doing the chaos mesh experiments accordingly on the shoe shop application or
Sock shop, yes, sock shop.
chalk shop.
Chaos Mesh, like maybe I will not be doing on. I don't know. Like let's see, because Chaos Mesh we won't be going that deep as Gremlin, because mainly studying all chaos attacks, everything. I'll be mainly using Gremlin. Chaos Mesh, I will be showing you like the basic setup and maybe 1 or 2 attacks. I will not be going all attacks, because covering
Okay,
both tools fully is difficult. But obviously all the attacks you will learn using Gremlin, and you will learn using Chaos Mesh how to set up the Chaos Mesh. Then the same attack you can run on Chaos Mesh. You can research some little bit. Okay, I will share the materials with you all.
okay.
Yeah,
So, sorry, it might be
yeah,
irrelevant, but I heard about the litmus chaos,
yeah.
and
All are
I
tools,
also
all the
heard
tools.
like.
See, now the thing is, right, in this market currently there are some 20 to 30 tools, okay, which you cannot learn. But
Mhm.
the problem with this is, like, everyone is releasing a new tool based on Chaos Monkey's source code, which is a little bit annoying also, because how you choose a tool. So that's why, as I said in the first session also, in interviews we never ask you which tool you worked on. We just ask Chaos concepts, different attacks, what you did. Like what you did in your chaos engineering, like let it be chaos mesh or gremlin, what you did, that has to be clear. Okay, if that is clear,
Okay.
obviously people know. Once you get into, like for example, if my organization is using powerful seal, it's fine, you can easily cope up with it because the base is same for all the fundamentals. Yeah.
Okay. So
Yeah.
if we compare Litmus Chaos and Chaos Mesh, so you
Mhm.
find Chaos Mesh better?
I find it better because it has a good UI and all comparatively. So it's more sort of a trade-off between expertise and non-expertise. Okay. So chaos mesh can be easily understood at an intermediate level, but litmus chaos, what happens is that it is little bit you need a bit more knowledge on coding side. Okay. So that's the problem there.
Okay. So
Yeah.
will you be able to share some material on Litmus Chaos or other tool as well,
Yeah, I
whatever
will.
you
I
have?
will share. Yeah, I will share. Sure.
Oh,
Yeah.
okay.
Yeah. So the tools which I have worked on till now is I worked on Chaos Mesh, Gremlin, Powerful Seal, and Litmus. Okay, these are the four tools. Toolkit we started as a POC, but yeah, it was not that efficient, so we dropped it.
One last question. This Chaos Monkey that was originally used by Netflix.
Yeah,
Why don't we as it is?
yeah, because only one attack is there, Sharma, in that. Like just you can shut down that also random node. You cannot even target a node there. That is the main problem. Main like it's just a very basic tool.
Okay, so that they just provided a basic version on top of that people are enhancing it, right?
Correct. Yes. Yes.
Okay.
Okay. Yeah. Then Jagan, you had a question?
Which, which, yeah,
Yeah.
but when compared to Chaos Mesh, right, I think Litmus Chaos has more number of experiments, right?
But as I said, see, 12 more than 12 experiments you will never do because what I'm saying, no, it's not about showcasing the experiments or showcasing the attacks. It's about finding issues in the system that we need to understand. So if you want to find an issue in the system, these 12 attacks are more than enough. Now think about it. Okay, Gremlin is a paid tool. Now why are they giving only 12? Right? There should be some reason
Okay,
behind that, right? They are taking such a big cost, license cost, and they are providing only 12. And when these open source are giving so many attacks and all, there will be a reason, right?
okay,
Because people are feeling satisfied with these 12 attacks. It's more than enough.
okay, okay. Those are
Yeah.
like frequently occurred attacks, right?
Yes, exactly. And they are keeping on updating it also. Like if new attack maybe in the market, like there is a new type of issue which is propagating, they will surely add that attack to the Gremlin.
Okay. So the
Yes.
So does
Gremlin licensing cost is more, or it will be
Sorry,
normal, like
more means like
how
see,
costly it will be? Yeah, yeah.
yeah, it will be based on the targets which you choose, but it's affordable, not that high as LoadRunner and all. Okay.
Okay, okay.
uh,
Yeah.
So
You are
you'll be
please
covering
Sharma.
that
yeah,
licensing and all, right?
Licensing I won't be covering because it's purely the as you would have seen in this, like it's contact us. So I won't be covering the cost and all because it's purely organizational based. How you what cost you will get it for. Okay, it's purely so
Okay,
for me it is totally free because I am as I said I'm closely related to Gremlin, so that's why. But yeah, other organizations have to buy it. But it will not be that
okay,
costly as other tools because they are very new tool and they want to market it more, right? So yes,
okay.
you can
so
easily even bargain. Yeah, yeah, Sharma.
yeah, so does Gremlin has open source edition as well?
Yes, no open source. Only free trial is there, which is 1 month, 15 days you can use, just like a POC.
Okay, and if I also want to use Gremlin for free, what I need to do like you?
So you want to use free trial, Gremlin? Is that what?
No, so you said right, it is currently free for you,
Yeah,
Gremlin,
correct,
because you
correct.
are a member
So
of it. Yeah.
yeah, yeah. So you are saying how you will get that?
Yes, yes, yes.
That is not possible because we are into this testing domain from very long and good
Mhm,
friends. It's through friends. Yeah, so
mhm.
yeah, so it's not very straightforward. Yeah,
Okay.
yeah, because it's around like it's a lot of dollars which they are giving us free, no? So it's not that straightforward. because what we provide them is beta testing. Before any testing is released, any new version is released, we test it and give them our viewpoints. Actually, they even pay that also for us, like not only free license, for each testing also they pay us. Yeah,
Oh,
yeah. Okay.
One last
uh
question, Vishnu.
yeah, Jagan.
How about the career options in chaos engineering when compared to
It's
like performance engineering?
Yeah, so it's more sort of, see, like you should have learned performance engineering, let's say, 5 years back, or like performance engineering specifically. I'm saying, okay, not testing. If you would have learned 5 years back, you would be now the most apt candidate for any organization within this 5 years. Okay, so similar to that, chaos engineering is also like that. If you start now, obviously you will have an edge over other candidates in the next 1 or 2 years. But now if you take just now, it will be like a add-on means, like if you are a performance engineer and if you want to switch the organization, or if you want to grow in the organization, you can use this extra domain knowledge to do that. Okay, so that's the viewpoint I have. And market is obviously very much burning on chaos, and surely there is a lot of demand which is coming, especially due to AI also, because AI is making the systems further complex. And surely, yeah, there won't be any like room left where you can put a thing in production without chaos engineering activity, because nowadays SREs are handling it, so it's not coming in the mainstream. But there will be some time when it's more sort of like, let's say, down the line 10-15 years, maybe the developers were running the Jmeter scripts, but now it's not like that, right? We have performance engineering, performance testing. Similar to that, now currently what is happening, chaos engineering is handled by SREs, but there will be a time when that will get split. Like SREs will be handling totally the infrastructure, chaos engineers will be handling chaos engineering. So that will happen.
Got it.
Yeah. Okay, it's
oh, we will be
almost 8.
doing a
Yeah.
table comparison, right?
Yes,
With
yes,
all
we
the
will be doing.
tools.
Yes. Correct. Yes, we will. Yeah. Okay. So have a good day, everyone, and thank you all for joining. Meet you tomorrow. Thank you.
Tomorrow is the session. Tomorrow is
Thank
Saturday.
you.
Oh, sorry. Today's Friday. I lose the time also sometimes. Yeah. So yeah, then it's on Monday. Okay. Sorry for that. Yeah. No
Okay,
sessions
okay,
tomorrow. Have a good weekend, everyone. Thank you.
okay. Thank you.
you.